We're going to start off Unit 2, and it tells us about the concept of the derivative. This is going to help us look at how functions are changing at specific points. To start things off, first we're going to take a look at average rate of change of a function. So if I take a look at this really fancy graph I have, I've got 2 points on my graph, a comma f of a, b comma f of b. And if I want to define the average rate of change, how that function changes over that interval, I need to know what a and b are, then I could find the y values for my function. So we call this AROC, average rate of change. If you take a look at this formula, this really just is your slope formula. Oops, right here. That's just the slope formula, y2 minus y1 over x2 minus x1. And it is telling us the slope of a line that passes through those endpoints on the interval on my graph. We call this a secant line because it passes through 2 points of a graph. Now this would tell me how my function changes on average over that interval, hence average rate of change, or AROC. We want to find instantaneous rate of change. How can we find at a specific point how my function is changing, not over an interval? So obviously we can't just go to one single x value because b and a would be equal, and we'd have division by 0, which is no bueno. So what do? Well, this is going to be a limiting process. We know about limits. We just spent an entire unit on them. So I'm going to look at b, that second x value, and I'm going to move it a little to the left. If I move b a little to the left, that means that my new function value is going to be a little bit to the left as well. And I can find this secant line in blue. I can find its slope. And then that will be different because obviously that has a different angle, different tilt to it. And then what I could do is move b even closer and find a new secant line slope. And each time I'm plugging into f of b minus f of a over b minus a, and yet I can move closer, and yet I can move closer and closer. And as I move closer, I'm going to determine a trend in these slopes. Those slopes would approach a value. That would be the limit as b is going to a. I'll get even closer. That's going to be the limit as b gets close to a of that slope formula, f of b minus f of a over b minus a. This is called instantaneous rate of change. This particular limit is how we're actually going to define the derivative. We call this f prime of x. We'll use that notation and talk more about that in class. What does that tell us? Well, it tells us at a specific x value, so for this case at x equals to a, how fast is my function changing? It's very different than over an interval. Now, most people actually introduce the derivative in a slightly different version, but it means exactly the same thing. Instead of using b and a, what we're going to do is use x and x plus h. In other words, we're going to move forward from x h amount. And what we're going to do with that same process is we're going to decrease the value of h. So here I have h is some number. H is going to be smaller this time. So x plus a little less, and then x plus a little less, plus a little less, et cetera, et cetera, et cetera. We're going to get really close. And if we take the limit as h approaches 0 of f of x plus h minus f of x all divided by h, this really is the same thing as we saw before up here. It's the same limit. We're just using a different notation for b and a. We're using x and then x plus h, but it's the same thing. So we get this limit, which is what we define as the derivative of a function at a point. So this is instantaneous rate of change. So what are some takeaways? So f prime, it's a notation, as I mentioned, we'll talk about in class. Okay, so what are some takeaways? Well, AROC, or average rate of change, that is the slope of a secant line that passes through the graph at the endpoints of an interval. I need to know the interval, and I need to know the function. If I don't have those two things, I cannot find AROC, or average rate of change. IROC, or instantaneous rate of change, that is the slope of a tangent line. So a line that hits the graph at one single point. So I need to know that single point. And then the derivative of a function tells us IROC. It itself is a function, which tells us if instantaneous, or what the instantaneous rate of change is at a specific x value. Okay, so when can we find the derivative? Okay, so when can or can I not? That's only when this limit exists. Not all limits exist. We've seen plenty of non-existent limits before. So if this doesn't exist, that means that we say the function is not differentiable at a point. So graphically, this means that we can find a, emphasis on the word a, meaning singular, tangent line. So let's take a look at this graph here and try to determine when we can or cannot find the derivative or the instantaneous rate of change. If you kind of move your hand or your finger along the curve of this graph, you can kind of see or imagine many, many different tangent lines, except there are a few sort of red flags here. Let's take a look at x equals -6. I could find this tangent line because it passes through that one single point of my graph, but I could also find this one, and that could also find like a whole bunch of other ones. In other words, the limiting process won't give me a single specific value of that slope. So here it's like basically undetermined. Also, if I take a look at x equals a -1, I cannot have a tangent line to that graph because there's no point on my graph there. Nor could I have a tangent line at x equals a 2 because it's like going to hit one part of my function. What I'm getting at here, points of discontinuity. So anytime you have these sharp points here, like at x equals -6, or we call those a cusp, or anytime you have points of discontinuity, like -1 and 2, you cannot have a derivative. Also, I should have highlighted x equals 5. We cannot find a derivative either because that's one of those sharp points. That'll do it and should give you more than enough information to answer those questions on Schoology.